Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of quadratic domain and range. This is standard A.6A in the great state of Texas, and we are using item number 11 of the 2023 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a statement about this function here, and we need to find which statement is true. It is a domain and range question, and I can tell you that it is going to be a quadratic function because it is what we call a degree of 2. It's got that exponent. So anytime it's squared, right, you're going to have a parabola that's either going to face down or it could possibly face up. Now we can tell real quick it's actually going to be facing up simply because it has a positive leading coefficient. Right, so if we look at our reference materials, we're going to see right down here at the bottom, there's going to be two of these that are going to be very important. So we're going to need, let me make sure that is back on. So we're going to need this standard form, because that's what they give it to us, right? This f of x equals ax squared plus bx plus c. That's the form they give it to us, right? So I'm going to put it right underneath there so we can see how it lines up. 5x squared minus 20x plus 12. So that means my a equals 5, my b equals negative 20, my c equals 12. I don't really need the c, and that's fine. We also need this axis of symmetry. There's a few different ways to solve this, but I'll choose the axis of symmetry just to show you what that looks like. And so what that axis of symmetry is, that's going to try to figure out, all right, so what is the x value in which your parabola is going to either find its lowest or highest value, depending on which way it's opening. We know it's going to be the lowest value. So I need x equals negative b over 2a. So if I can find that, then I can plug that back in. What does that x equal? I can plug that back in and find that y value. All right, so my negative b is going to be negative 20, and then over 2a is going to be 2 over 5, so that's going to be 20 over 10, so that's 2. All right, so at x equals 2, right, I'm going to find the low point of my parabola. Now, it doesn't help me with my domain and range, but if that's x equals 2, then what is that y? Well, I'm going to plug this y back into that right there. So I'm going to say n of 2 equals 5 and then 2 squared minus 20 times 2 plus 12. So that's going to give me 5 times 4. Let's see, 5 times 4. Flip those, but that's fine. You know what I'm doing. Minus 40 plus 12. So that's 20 minus 40, that's negative 20 plus 12. All right, so it looks like negative 8. So my vertex is going to equal my x of 2, my y of negative 8. Now, how does that help me with these right here? Well, the domain is not really going to be limited here, okay? Because unless there's something within this statement that is really restricting the domain, most of the time your domain is unlimited. It's all real numbers. It's going to be expanding side to side for infinity for most of your parabolas here. So it's the range, and as you can see, it's upward facing. So we need something that is n of x is going to be greater than or equal to negative 8. So here's, right, so I've got 2, negative 8, something along this line right there. There's my 2, negative 8. So anything above that is going to work. So I'm thinking it's b, but then obviously we can just go ahead and, plug this in. Let's see what happens when we plug it into the calculator. So I hit my y equals. I'm going to go ahead and enter that in, and let's go ahead and hit my graph button. We'll let it graph, and then in order to find that, I want to trace, right? And let's bring it all the way down here to the bottom. And look at that. It looks like it's right around that negative 7.99, which is negative 8, and anything greater than that is good, so my answer is B.